Next, determine the constant, that is constant means x to the power of 0 in 4x cube minus 5x to the power of 16. Now what is the given expression? 4x cube minus 5 by x whole to the power of 16. We have to find the coefficient of constant or coefficient of x power 0 or simply constant term, right? Now, the coefficient of x power k in general. What is the coefficient of x power k in the binomial expansion x plus y whole power n is nc n minus k x to the power of k y to the power of n minus k. Right? Now see, same here. Here x is equal to 4x cube, y is equal to minus 5 by x. That means we are rewriting this one in terms of 4x cube plus of minus 5 by x, right, whole to the power of 16. This is x, this is y, right, x plus y whole to the power of n, where n is equal to 16. Right, now here clearly we are writing x is equal to 4x cube. We are comparing the given function with the standard form, right, x plus y whole to the power of n. Here x is equal to 4x cube and y is equal to minus 5 by x, n is equal to 16. The coefficient of x power k is equal to 16 in 16 minus k, 4x cube whole power k minus 5 by x whole power 16 minus k by using the formula 16c 16 minus k 4 power k into x to the power of 3k into minus 5 whole to the power of 16 minus k 1 by x to the power of 16 minus k. That means we are applying this formula. AB whole power can be written as a power n into b power n. Another formula is a by b whole power n is equal to a power n by b power n. Simply we are applying the basic formulas here. 5 minus 5 by x whole power 16 minus k can be written as minus 5 whole to the power of 16 minus k by x to the power of 16 minus k. Right? Now, here 16 minus k, 4 power k as it is. Now we are simplifying this one. Minus 5 to the power of 16 minus k into x to the power of 3k. Now here it is in the denominator. We are transporting this one to the numerator. Therefore it becomes x to the power of k minus 16. See, 16 minus k becomes k minus 16. Here once again after simplifying, here x to the power of 3k into x to the power of k minus 16. This is nothing in the form of a power m into a power n. That means a power m plus n. Right? X to the power of 3k plus k minus 16. Therefore x to the power of 4k minus 16. If you add those powers, you will get this one. Now, but we need to find the coefficient of x power 0. X power 0 is nothing but constant term, no? Here that means k. Put k is equal to 0 in this general expansion. That means 4k minus 16 is equal to 0. K is equal to 4. The constant or the coefficient of x power 0 is equal to 16 12 4 power 4 minus 5 whole to the power of 12. That means 16c12 4 to the power of 4 5 to the power of 12, because minus 5 to the power of 12 is even power, no? That's why even terms of minus is nothing but plus, minus into minus and so on, even number of times, right? By to the power of 12 only. This is the coefficient of x power 0 in the given expansion of 4x cube minus 5 by x whole to the power of 16. Right? The next one. Determine the sequence generated by 1 minus x 1 minus 4x whole to the power of minus 1 by 2. Determine the sequence generated by 1 minus 4x whole to the power of minus 1 by 2. That means simply we have to expand by using binomial expansion. We know that 1 plus x whole to the power of n is equal to nc0, right? nc0 into x power 0 plus nc1 into x power 1 plus nc2 into x square plus nc3 into x cube plus nc4 into x power 4 and so on, right? Similarly, here we are applying the same formula. This is 1 plus x whole power n. N is nothing but here minus 1 by 2 minus 1 by 2 c0 into 1 power 0 here minus 4x power 0, right? We are comparing the given function or given this one with the standard form. That means 1 plus x whole power n. Here n is equal to minus 1 by 2. Capital X is equal to minus 4x here. See, we are comparing this the standard form, right? Now nc1 minus 1 by 2 c1 minus 4x to the power of 1 nc2 minus 1 by 2 c2 minus 4x whole square, nc3 minus 1 by 2 c3 minus 4x whole cube, right? And so on. The now here the nth term is x power n is equal to minus 1 by 2 cn minus 4 to the power of n. Here x to the power of n coefficient I am writing, not the nth term. See, if I want to write the nth term, this is the nth term, right? I am writing x to the power of n coefficient minus 1 by 2 cn minus 4 to the power of n only, right? No need to simplify this one, right? Simply I am going to determine the sequence generated by that one. Okay. Next, see, let a0, a1, a2 so on be the sequence of real numbers. The function f of x is equal to a0 plus a1x plus a2x square plus a3x cube so on. Summation I running from 0 to infinity ai x to the power of I is called the generating function for the given sequence. This is nothing but a formal power series. Man introduction class lo undi. Once again we are writing the same thing. See, in the first page number 1, this is called formal power series. No, ax is equal to summation r running from 0 to infinity an x power r, or the ar x to the power of r is called the generating function for the sequence, right? For the sequence capital A is equal to small ar, r running from 0 to infinity. Here a of x is called the a of x generates the coefficient, that means generate the terms of the sequence. This is nothing but the formal power series a0 plus a1x plus a2x square plus a3x cube and so on plus an x to the power of n plus so on is equal to summation r running from 0 to infinity a r x to the power of r. This is called a formal power series. This is there in the page number 1, right? Here page number 8 also we are repeating the same thing, but here we are clearly writing 1 plus x expansion 1 plus x whole power n by using binomial theorem. That can be written as nc0 plus nc0 can be written as shortcut notation is n0, right? nc0 plus nc1 x power 1 plus nc2 x power 2 plus nc3 x cube plus so on ncn x to the power of n, right? So see the terms, this is the binomial expansion. Now we need only the coefficients, so therefore the coefficients are what? nc0, nc1, nc2, nc3 and so on ncn. Rest of the terms are zeros, right? Now therefore 1 plus x whole power n is the generating function for the sequence nc0 comma nc1 comma nc2 comma so on ncn comma 0 0 0, right? Now here 1 by 1 minus x, which can be written as 1 minus x whole to the power of minus 1. This is the expansion of this function or this expression. 1 minus x whole power minus 1 can be written as 1 plus x square plus x cube plus so on, right? In summation form, summation I running from 0 to infinity x power I. Okay, now here there are first differentiation first order differentiation, right? That means ordinary differentiation with respect to x. The differentiate the given above series with respect to x, we are getting this one d by dx of 1 by 1 minus x is equal to d by dx of 1 minus x whole to the power of minus 1. Now differentiation of x power n is n into x to the power of n minus 1. We are applying the same formula. D by dx of 1 minus x whole power minus 1 can be written as minus 1 into 1 minus x whole to the power of minus 1 minus 1. That means differentiation of x power n. Differentiation of x power n can be written as n into x power n minus 1. No, the same formula we are applying here. Into differentiation of minus x is 1. Okay. Now similarly here right side expression also we are applying the differentiation. This is the notation, right? This is the differentiation function. D by dx of entire expression. D by dx of 1 is 0. D by dx of x is 1. Differentiation of x square is 2x. Differentiation of x cube is 3x. Here differentiation of x power 4 is 4x cube. Differentiation of x cube is 3x square, and so on. No, right? Here 1 into 1 minus x whole to the power of minus 2 is equal to 1 plus 2x plus 3x square plus 4x cube, and so on. You have to remember this formula. 1 by 1 minus x whole square or 1 minus x whole to the power of minus 2 formula is this one. 1 plus 2x plus 3x square plus 4x cube plus so on. Here 1 by 1 minus x square is the generating function for the sequence 1, 2, 3, 4 and so on. Right? Now ఇక్కడ మనం ఫస్ట్ పేపర్లో ఏం చెప్పుకున్నాం ఇక్కడ see the formal power series is the generating function for the sequence. See, the further sequence means the coefficient of x power 0, x power 1, x power 2, x power 3 and so on. Right? Here what are the coefficients of x power 0, x power 1, x power 2, x power 3 and so on? Here 1, 2, 3, 4. These are the coefficients, right? Now therefore this is the generating function which generates the coefficients, right? The coefficient are the terms of the sequence. Now 1 comma 2 comma 3 comma 4 comma 5. These are the coefficients of x power 0, x power 1, x power 2 and so on, or you can say these are the terms in the sequence. Next one, see another formula. 1 by 1 minus x whole square is equal to, we know 1 plus 2x plus 3x square plus 4x cube and so on. Now we are multiplying by x on both sides. We are multiplying by x, right, on both sides. Here x by 1 minus x whole square is equal to x into this one, right? And x into, that means x into 1 is x, x into 2x is 2x square, x into 3x square is 3x cube, x into 4x cube is 4x power 4 and so on. X by 1 minus x square is equal to 0 plus x plus 2x square plus 3x cube plus 4x power 4 so on. Now this is the generating function which generates the coefficients of x power 0, x power 1, x power 2, x power 3 and so on. No, right? See what are the coefficients here? 0, 1, 2, 3, 4 and so on. This is the generating function. X by 1 minus x whole square is the generating function for the sequence 0, 1, 2, 3, 4 and so on. What are these? These are the coefficients of x power 0, x power 1, x power 2, x power 3 and so on. Similarly, please go through this derivation also. And so once again you are differentiating this one. Here we are applying dy by dx, sorry, u by v formula, right? I will explain this one later. U by v formula we are applying. Differentiation of u by v is equal to v into u dash minus u into v dash by v square. Right? By applying that formula you will get another result, another formula. Okay.